In this video, we're going to start lesson 3.2. We're going to be talking about constructing perpendicular bisectors, and we have a couple investigations to do. So first I want us to draw line segment AB. And so I'll just draw a line segment. And then as best you can, draw line CD perpendicular to AB, where the point of intersection E is the midpoint of AB. Okay, so first of all, I want to find the midpoint. To do that, again, I'm going to have to look and see. It looks like AB is about 51 centimeters. So 51 divided by 2 is 25.5. So 25.5. So here's my midpoint. We're going to call that E. I'll mark it as a midpoint. And then because I want it to be perpendicular, what I'm going to need to do is use my protractor. I'm still with the large one. So let me reconfigure this. I'll put the protractor the right way. And it looks like this is 90 degrees. I wish that would have gone through point E a little bit better, but that's all right. Again, because it's CD, line CD, I'm going to label points C and D. It doesn't really matter where C and D are. Remember, this could be line CE as well. So it says, this line is what we would call a perpendicular bisector of segment AB. But we actually have a couple different things. So before we do this investigation, I'm going to actually watch the video on the vocabulary. So I'm actually just going to embed it right here. So the vocabulary. So a segment bisector is a line, ray, or segment that passes through the midpoint of a given segment. Let's make a quick sketch of this. I have to have a segment to have a midpoint, because if I don't have something with a finite length, then I can't find the middle of it, right? You can't find the midpoint of a line, it's infinite. So I can have a line go through this. I can have just a ray go through this. I'm going to mark that as midpoint. Or I can have another segment go through it. And if you can imagine, there's an infinite number of these segment bisectors. So there's an infinite number. They're not coming at any specific angle. They're just kind of passing through that midpoint. And again, they could start at the midpoint like a ray and move toward any direction. The perpendicular bisector is similar to a segment bisector. So it is a segment bisector, but it's a special kind of segment bisector because it's perpendicular. So again, it's a line, ray, or segment that passes through the midpoint of a given segment. And makes a 90-degree angle at the midpoint. So the midpoint is the vertex. So again, if I have a segment, I have a midpoint. The perpendicular bisector must form a 90-degree angle there. Now again, this could be a line, so I could extend it down here, it could be just a ray, it could be just a segment. The point is, no matter what happens here, a line, ray, or segment, they must all be part of the same general line. So we say that the perpendicular bisector is unique, meaning there is only one. When it comes to midpoints, there are two special definitions that we associate with midpoints and with triangles. And we're going to be using that in our constructions once we learn how to construct a segment bisector. So I'm going to go through and also tell you those right now. So a median is, and this is a median of a triangle, a line segment that connects a vertex of a triangle to the midpoint of the opposite side. So I'm going to sketch, again, a very generic triangle. Let's say I'm going to go from this vertex to this side to draw my median. So if I found my midpoint, which again I would label as a midpoint, and I connect this vertex to this midpoint, the midpoint of the opposite side, this is what a median is. But because we have 3 vertices, we actually have 3 medians. So you could also find a median, let's say, from this vertex to the midpoint of this side. So this is also a median. So a triangle has 3 medians. A triangle also has 3 mid-segments. So what is a mid-segment? It is a line segment that connects a vertex. Excuse me. That is not true. It is a line segment that connects the midpoints of 2 sides of a triangle. Again, I'm going to sketch a generic triangle. Let's say I find the midpoint of this side. That doesn't look like it's perfectly in the middle, but let's pretend. And I find the midpoint of this side, and I connect these 2 segments, or these 2 points, excuse me. That is a mid-segment. Again, there are 3 medians, there are 3 mid-segments. We are going to be exploring more about medians and mid-segments in future chapters, but for this chapter, we're just going to use our construction techniques to construct them and then just kind of get a handle on understanding that vocabulary. All right, back to our investigation. We're going to be using patty paper. So grab yourself a piece of patty paper. Okay. And what we're going to do, step 1 says to just draw a segment PQ. And you can use the whole piece. It doesn't have to be super long. I'm going to actually set a blank piece of paper down under my patty paper so I'm not tracing on top of words already. And we're going to label this PQ. Again, don't make it too small because then it will be too hard. So then what we're going to do, step 2, is to fold endpoints P and Q so that they land exactly on top of each other. So I hope I can do this so that you can see. So it doesn't really matter if I fold it front ways or back ways, but I want to fold my patty paper. See, like right now it's not good because P and Q are not on top of each other. So I'm going to slide my patty paper. So point P is exactly on top of point Q. The segments are on top of each other. And then we're going to crease that. And when I open it up, because it's patty paper, you should get like a distinct line here. And then what we are going to do is we're going to draw a line in that crease. And I think the better you make this, the nicer it's going to be. All right, so that's what we wanted to do. And then the question is, use your ruler and protractor to verify what is the relationship of this line to segment PQ. So what can we say about this line with our segment? Well, it does look like this is congruent to this, which I could use my compass to verify that. I could use that's about 27 centimeters. And it does look like it's making a right angle. So I can say that this is the perpendicular bisector, okay? We are going to glue our patty paper to this spot when we're all done. But for now, we have to flip to the next. We have one more piece of this investigation to finish off our conjecture. So I'm not going to glue it quite yet. Okay. So then what we're supposed to do is to place 3 points on the perpendicular bisector. So on this line we just created, we're going to put 3 points on. I'm actually going to say let's just put 2. All right, so we'll do point A, we'll put up here, and point B, we'll put down here. And notice how I tried to make A a little bit longer from the midpoint and B a little bit, or sorry, A shorter and B longer. With your compass, compare the distances of P to A and A to Q, and then the same thing. So I'm going to use my compass. If I set my compass to the length from P to A, and then, oops, if I go over here, I notice, well, look at that. It's exactly the same. So the word we would use there, same distance, would be equidistant. Do you think that's going to be true from P to B? So now it's not going to be the same distance as P to A, right? Because B is a little bit farther from that midpoint. But we have this distance here. If I move my my compass over here, yes, that is also the same distance. So what that means is, if a point is on the perpendicular bisector of a segment, so if it's on the perpendicular bisector, then it's equidistant from the endpoints of that segment. What you can do now is go ahead and glue your patty paper to this side of the investigation. If it makes you feel better, you can kind of cut it out a little bit and then glue it. You can just kind of glue it to the side just so that you have a good handle on it. So that is the perpendicular bisector conjecture and our first investigation using patty paper. Great job.